హలో గాయత్రి అంటే ఎవరమ్మా? స్టూడెంట్ అమ్మా, ఫ్యాకల్టీ అండ్ హలో హలో
హలో సార్. హలో హలో సార్.
Good morning, all. Am I audible? Yes, am I audible?
Except Kavya madam, remaining Anta, please leave the classroom. We are going to sharing a YouTube link. Remaining, all leave the classroom except Kavya madam.
Yes, good morning, everyone. Am I audible?
Yes, ma'am. Yes, madam.
Okay, sir. Thank you.
From women point of view, Gayatri can stay back. Only Gayatri from KIET W can stay back. Remaining have to leave.
Yes. So today I'm going to teach about transaction concepts, transaction states, concurrent executions, and serializability.
Ma'am, this is a clear instruction from me. We are going to sharing that YouTube link, everyone, except Gayatri and Kavya madam. Remaining can please leave the Gmeet link. Am I clear? My instructions are clear? except Gayatri, Kite, Kavya madam. Remaining, please leave the group. Dhanush, you can remove remaining ones. Madam, you can start your session, madam.
Okay, sir. Thank you. So before going to see the transactions concept, let us know about the definition of the transaction. What is transaction? So if you are having any doubts, you can post your doubts in your comment box so that I can clear your doubts. Okay. So
Ma'am, can you please
transaction
wait for
concept.
2 minutes, madam?
Yes, yes, sir. Sure.
Here that broadcasting is not happening, but just 1 second, madam. I just
Okay, sir.
inform you.
Okay.
Madam, you can continue, madam.
Okay, sir. Thank you. One minute, sir. So coming to transaction, transaction is a unit of a program execution that access and possibly updates various items. So transaction, we know that while using the phone pay, we are doing some types of transactions, right? If for money transfer, okay, that we call it as a unit of a program. Unit of a program execution means after transferring the amount should be either present in account A or account B. Suppose two accounts are there, account A and account B. So either the transaction should be successful in account A or account B. So a transaction is nothing but it is a unit of a program execution that access possibly updates various data items. Or also we can say another definition for transaction. A transaction is a unit of program whose execution may change the content of the database. See, after doing the
Ma'am,
transaction,
just
sir,
2 minutes, madam. Kavya, madam.
sir.
Sorry to interrupt you, madam. Madam, you can continue, madam.
Okay, sir. So let us see the other definition for the transaction. Transaction is a unit of a program whose execution may change the content of database. So here, suppose I have done a transaction through GPay or PhonePe, whatever it may be. So mobile banking or banking transaction. So after doing my transaction, the content, whatever the content present in the history, it will be changed, right? So the transaction is a unit of a program whose execution may change according to the content of database may change. So for example, banking database. Let us take one example, banking database. So here the content will be changes according to the changes done by the user. Why? Because today the transaction is half 50 records. Tomorrow it may increase to the 1,000 records according to the usage of the user. Right? So transaction is nothing but it is a unit of a program execution that access and possibly updates the various data items, and also a transaction is nothing but it is a unit of a program whose execution may change the content of database changes. Example is banking database. Suppose here if you take example transaction to transfer rupees 50 from account A to B, right? So what is the example? Transaction to transfer rupees 50 from account A to B. So what is the thing we need to do first before doing the transaction? We need to read, right? So each and everything will happen in transaction. Read and write. You need to take two operations, that is read and write. Okay, before going to do any transaction in transaction concept, you need to use the two keywords or two operations that are read and write. Okay, so transaction is to transfer 50 rupees from account A to B. Means first how you need to write read of A. Why? Because which is having 50 rupees in account A. That's why we need to read A. Then what is the operation we need to perform? A equal to A minus 50, right? So we need to transfer rupees 50 from account A to B, right? So that's why A equal to A minus 50. So after done with the read operation, then we need to next write. Write is nothing but execute. So this giving the instruction A equal to A minus 50, that will be executed, means the amount of 50 from A to B will be transferred. How? See, read B. Next, we need to perform the operation read B. Next, it is reading the account of B. Now, what will happen? This operation, this B equal to B plus 50 will become. Here, it will become minus 50. Why? Because we are transferring from A to B, right? So that's why here it will, we should give A minus 50. Then here it will be a B equal to B plus 50, right? So after that, execution is nothing but write B. Then only it is transferred from 50 rupees from A to B, right? Transaction to transfer rupees 50 from A to B is like happens like this. We need to perform two operations, read and write. First, we need to read the account A. Then we need to write the instruction that we need transfer A equal to A minus 50, right? Then it should transfer means we need to write of A. Write of A in the sense is execution. Okay. Then after doing this operation, next we need to see about the account to B. That means read B. Then A B equal to B plus 50, right? B. So in this way, you need to write the transaction programs. Okay. So this is the banking database to transfer rupees 50 from account A to account B. That's what I said. No, it is a transaction of unit program whose execution may change, according to the content of database change. So before changing this before doing this transaction, the account may has 100 rupees and after account B has 50 rupees. So after transferring this 50, the account B will be become 100 rupees and account A will become 50 rupees, right? So that's what the changes where occurs, that we call it as a transaction. A transaction is a unit of a program execution whose execution may change according to the content of database. Clear? So here we use the operations read and write to change the or to perform the transactions. Next. So to perform these transactions, we have like every time I said in DBMS, the good quality or good features of the DBMS is consistency. Means the data everywhere present in multiple locations that should be in a consistent state. That should be everywhere the data should be present. That should be same. Then only we call it as a database consistency. So if at all it is in inconsistent mode means or inconsistent statement, the data where it is present in multiple locations are not same. That may leads to data inconsistency. That means the results may be inaccurate. So the accuracy to maintain the accuracy in DBMS, we need everywhere the data present in different multiple locations that should be same. That we call it as a consistent data. Okay. So it consists of so many operations. Like if you observe here, okay, if you observe here, we should start with begin and end with end statement. Okay. So here we need to, before starting write the operation, read operation, we need to write as begin. Then only we should start read operation. After completion of the transferring the transaction, so we need to write the statement as end. Okay. Next. So what is the consistent operation or consistency means here before transaction if see here the before transaction the transaction is A plus B or this is having some 100 amount. Okay. B is having some 200 amount. Okay. So after doing the transaction also will the value is same means we can treat it as a the data is in consistent state. So before transaction the A plus B is suppose think it of like this 500. After transaction the A plus B is also 700 means the transaction whatever the database we say it as a the database is in consistent state. Otherwise, it may lead to inconsistency state. Okay. So to make the database in consistent state, we use some properties of transaction that we call it as the acid properties. Okay. So why we need to use the acid properties means to make the database in consistent state, we use acid properties. Okay. Till now clear or having any doubts? So next coming to the properties of transactions. So acid properties. So why we need to use acid properties to make the database in consistent state? We use properties called as acid properties. So acid properties A is nothing but atomicity, C is consistency, I is isolation, D is durability. Okay. So let us see the first one, acid properties. In that first one is A, atomicity. So atomicity is nothing but here it states the transaction must be atomic means it should be a atomic means either all of its transactions are executed or none of its operations are done. Okay. So what is the meaning of atomic here? Here all the operations should be done or should not be done. Okay. That we call it as a atomic. For example, if you take the phone pay transaction. Okay. So if I want to transfer my amount from account A to account B. Okay. So some other person. So either if I'm doing any transaction, any failure occurred means the transaction may not be successful and it may leads to some processing state. That means what here the amount will be deducted in A, but it is not shown in B, right? So that may leads to inconsistency. Here, what happened with the atomicity? Either all of its transaction done means it should be successful or it should not be done at all. That may leads to inconsistency, right? So this is called as the atomicity. What is atomicity? Atomicity means either all of its transactions should be successful or none of the operations should be done. Okay. Suppose GPay or PhonePe transaction, if you take, okay. So if I want to transfer the account from A to B, okay, the transaction should be either successfully done or should not be done. Okay. If any failure occurred means what will happen here? The transaction will be deducted from the A, but it is not shown in B, right? So this we call it as the atomicity. Atomicity is nothing but either all of its transactions should be successful or should not happen at all. That we'll call it as a atomicity. Atomic meaning either all of its transactions should be successful or should not happen at all. It is called as a atomicity. Okay. So next, let us see with the example. Here, we'll use two concepts like abort and commit. Okay, so abort and commit. Before going to see that, let us see the example here. Read a equal to a minus 50. Suppose here it is also going to transfer a transaction rupees from 50 from A to B. So read of A equal to a minus 50. Write of A means here this A part is done. Now it should be reflected in B, right? So either all of its transactions should be successful and none of its operations is called as a atomicity. Read of B equal to B plus 50, right of B. So this is called as a atomicity. Why? Because all of operations or transactions are done successfully. What is the meaning of atomicity? Either all of its transactions should be successful or none of its operations means we should not perform any operations on this. That we call it as a atomicity. Okay. So here, if we are doing the same transaction, suddenly any error or any failure occur means will be lost the data and the data will be leads to inconsistent state. So to perform or to do the atomicity operations, we need to have two operations that is abort and commit. Two operations. We need to perform two operations. Abort is nothing but change is made to the database are not visible. Abort is nothing but stopping. Okay. So in middle, whatever the transaction are performing, that should be stopped. That call it as a abort. Changes made to database are not visible. That is called as a abort. Coming to the commit, changes made to the database are visible. See here, if you observe the transaction was successful. This we call it as a commit. Successful is nothing but commit. Commit in the sense successful. Okay, whatever the changes made in the database are visible are called as a commit. So to whatever the data which is leading to the inconsistency, we can recover by two things. What is the two operations? Abort and commit. Okay. So abort is nothing but whatever the changes made in the database are not visible. Why? Because we stopped the transaction. So that is called as abort. What is the meaning of commit? Changes made to the database are visible called as commit. Okay. So here, if the transaction failed after step 3, okay, if the transaction fails after step 3, before step 6, money will be lost, right? Yes or no? So here, the amount is deducted. Yes or no? From A minus 50 means the amount is deducted. But here what happens? The amount will be or money will be lost leading to the inconsistent state. What happens if any transaction or any system failure occurred in the step 3 means so it is not reflected in the B account. Okay. So this will lead to inconsistent state. The database will be in inconsistent state. So the system should ensure that updates of a partially executed transaction are not reflected in database. That is what atomicity. Okay. Suppose two transactions T1 and T2 are two transactions are there. Okay. So if I want to transfer 100 rupees from account A to account B, so A is having, suppose think it of like this, A is having 100 rupees. A is having 100 rupees. Sorry, 500 rupees. In total, A account, it is having 500 rupees. Okay. So, in B is having 200. In B's account, it is there 200 rupees. Okay. So, transaction 1, read of A wants to transfer some amount 100. Okay. Now, write off A. So, what will the value of A here? After transferring this A to B, this will become the value as 400. Yes or no? This will become as a 400. Next, what will happen? Suppose the read B is having some amount of 200. So if I want to transfer here 100, right? 100. So what will happen here? The amount will be added here, right? So the what is the value of B will become now 2 from 200, it will become as a 300. After execution of this step, it will become as a 300. Clear? Okay. So atomicity is nothing but either all of his transactions should be successful or none of operation should be done. So if any failure occurs in the step 3, so money will be deducted and it will lead to data inconsistent state. Okay. So this we call it as a atomicity. So if for transferring A to B, if you observe here, what is the value of A and B? A is 500 and B is 200, means 700. So after doing the transaction, what is the value of A? 400. After transaction, what is the value of B? 300, means 700, 700. Before transaction, it is 700. After transaction is also 700. So this is called as a consistent state. The database is in consistent state. If transferring A to B before transaction, the system failure after T1 before T2. Okay. So suppose this is T1. This all comes under T1. Okay. So if the transferring amount A to B before transaction, the system failure after T1 before T2. So the amount A is deducted and not added to the account B. So this will lead to inconsistent state. Okay. So to overcome this problem, okay, atomicity is like any system failure occur means we lost here the data that may leads to inconsistent state. So if suddenly changes or any failure occur, what will happen? The whatever the changes made in the system will be unchanged. Okay, that is called as a abort, and after that it should be commit. So this is called as a consistency. To overcome these problems, we go for the next concept that is called as a consistency. What is the letter in the acid property? Second one, C. Consistency. C is nothing but consistency. So consistency is nothing but correctness of a transaction, correctness or accuracy of a transactions. Okay. So here in a consistency, integrity constraints must be maintained so that the database is in consistent state. Okay. So what happened here? Integrity constraint. Again, integrity constraint is nothing but we go for purpose of DBMS. There we learned about integrity constraints, right? So if I want to maintain the like a banking database, in that the column will be their account balance. So the column, I kept one condition, one constraint that account balance should not be null or equal to zero. It should have less than zero. Okay, such condition I have kept. What will happen here? If I'm trying to enter a zero, or I should keep, I left with a zero, means what will happen? It shows the error. Why? Because I have kept one condition that it should contain some value. That is what integrity constraint. The account balance should not be null or empty. Okay, null or zero. So here consistency is nothing but correctness. Integrity constraints must be maintained. By integrity, by keeping this integrity constraint, uh, we should maintain means in a database, it shows the database in consistent state. Then only it shows the correctness of data before or after the transaction. Okay. Suppose one table is there, like a roll number column. Student database is there, roll number. Without roll number, we cannot identify the student personally or a particular student from a class. Why? Because multiple names, same names is repeated in a class, right? 2, 3 names with having the same name with the same different people, right? So this we call it as a integrity constraints, nothing but correctness of the data. Okay. So why we should maintain the integrity constraints for a particular column means for a roll number, I have kept primary key. What is the reason? Why? Because it should satisfy the two conditions. Which one? Primary key. It should not be null or empty. It should have unique values. It should not be null or it should be empty, right? So this column, roll number column should satisfy two conditions. It should not be null or empty. It should have unique values. Means if I'm giving the duplicate roll number, suppose I am giving this 501 twice, means it will not take. Why? Why? Because I have kept one constraint, one condition that primary key. It should not be null. And what is the second condition? It should have unique values. Okay. This why I'm keeping to get the database in consistent state correctness to get the accurate data. While I'm fetching the data, I should get the correct values, accurate values. That is what consistency. Consistency is nothing but the integrity constraints must be maintained so that the database will be in consistent state. If at all the database is not maintaining any integrity constraints, means what will happen? The database may leads to inconsistent state. Clear? So suppose example here, sum of a comma b equal to sum of a comma b. Before transaction, it is 5 plus 200. Means the A account is having 500, B account is having 200. Here also coming to the after transaction, A account is having 400 and B account is having 300. Why? I want to transfer 100 from A to B means so the A will become now 400 and the B will become 300. So before and after the database is consistent. Why? It is having the same value 700, 700. So that is what consistency. What is consistency? Correctness of data means for correcting the data we need to maintain integrity constraints. Next, isolation. So what is the third letter? Isolation. Isolation is nothing but actions performed by the transaction will be isolated or hidden from the outside transaction until it's terminated. Okay, isolation is in the sense you need to remember the blind word actions performed by the transactions will be isolated. Isolated means hidden. Okay, so whatever the transaction we perform, that should be in hidden state. Okay, so until it terminates, it should be in hidden state. So the transactions will be isolated. Suppose, example, transaction T1 and T2, two are there. Okay, so if I want to transfer amount from A to B, rupees 50, what is the operation I need to perform? Read of A equal to A minus 50, write of A. So here what will happen in C? For example, here it is there. In step 3 and step 6, another transaction T2 is allowed, right? What is the step 3 here? Write of A. What is the value here? We need to transfer rupees 50 from B 50, right? So here in step 3, write of A and step 6, write of B. So the another transaction T2 is allowed. Okay. If T2 is allowed means there is maybe a possibility of getting the partially updated database which leads to inconsistent state. Okay. So here what will happen in T2? What it is giving some instruction? Read of A comma read B print A plus B. Okay. So here it is not performed fully, but it is T2 is allowed to do a partially update database. So this will lead to inconsistency. What is our main intention? After reading A, the execution done with the A means that uh, amount should be transferred to the B completely. Then only the other transaction is allowed, right? So here what is happening in isolation here? The step 3, after performing the step 3, T2 is allowed to do some partial updates, so which may lead to inconsistent state. So this we call it as a isolation. Isolation in the sense the data used during the execution of a transaction cannot be used until the first one is completed. So here until completion of the T1 transaction fully, T2 is not allowed. That we call it as a isolation. Okay. So isolation can be ensured trivially by running the transaction serially. Means after completion of one by one transaction is completed means the other transaction is allowed. If T1 is completing its transaction means T2 should be has to wait until completion of T1. Okay, clear? So values in T1 cannot be used by T2 until its first transaction completes its operation. That we call it as a isolation. Isolation is nothing but the transaction should be performed serially, one after the other. That what isolation is also called as a actions performed during the transactions that should be hidden. What should be hidden here? T should be hidden until completion of T1. Clear? So this is isolation. Now coming to the durability. What is the meaning of durability? Means all the updates done by a transaction must be permanent commit statement. Until we change values in database will not be removed. So what example we take means we can take the example like phone pay transaction only. So here, whatever the transaction, whether it may be failure or whether it may be successful, so the transaction history, whatever the transaction done to this so and so person, a particular person, that history will be permanently available in phone pay history. Yes or no? After making any changes also, the changes, whether it shows the processing state, whether it is failure or whether it is successful, all the history it is maintained in our phone pay transactions history page. Yes or no? Suppose I want to transfer account A to B. So now previous transactions it also shows after doing this transaction, it is also showing the next recent transaction, previous transaction, and old and some few years of transactions also it is going to show. That is what the whatever the updates done by a transaction must be permanent. Okay, whatever the updates done by a transaction must become permanent in a commit statement. Until we change the value, the database will not be removed. Okay. So until if I want to, if for example, we'll uninstall the phone pay app means then only the history will be gone, right? So until removing that one, the page will be remain same, right? All updates done by a transaction must be permanent. Until we change the value will not be removed. So that we call it as a durability. Once the user has been notified the transaction has completed or the transfer, the rupees has been taken place, the updates to the database by transaction must be persist is nothing but permanently saved. Even there is a software or hardware failure occurs. Okay. So whatever the transaction we have done to the particular person means it will be in a the page will be reflected. Okay. Then the transaction history it is going to show whether it is in processing or whether it is failed or it is successful. It shows everything permanently. So that is we call it as a durability. Clear? Till now clear? I hope you all understood or having any doubts means you can post your questions in comment boxes now. Anyone is there? Please respond so that I'll move to the next topic. Up to this clear or having any doubts? Next, simple transaction model. So simple transaction model will perform the two operations I said in previous slides. Two operations read and write. Okay. So the transaction access data using two operations. Read is nothing but which transfers the data item from X from the database to local buffer belonging to the transaction that executed the read operation. So what is the meaning of this simple transaction model is we can do the transactions in database management system using two operations that are read and write. Okay. So read is nothing but which transfers the data from the data item X from the database to the local buffer. Okay. So that local buffer will be belonging to the transaction that will start the execution to read the operation. So next one, write. Write means which transfer the data item from the local buffer to the transaction executed right back to the database. So read is nothing but whatever the transaction we are performing, like suppose data item X from the database to the local buffer. So what will happen here? This local buffer belonging to the transaction will be reading our operation. A A equal to A minus 50 is it is reading. Okay. So what is write operation? The transfer the data item from the X or A from the local buffer to the transaction executes to the database. So here after giving this instruction, it will write back to the database. That means it gives the acknowledgement to the database that it is done successful transaction. Clear? So simple transaction model will have two operations, read and write. What is the definition of read? Which transfers the data item from X from the database to local buffer belonging to the transaction that executed the read operation. Next, coming to the write operation, write of X or write of A. If you take here write of A, which transfer, write in the sense execution. Okay, write in the sense execution, which transfers the data item from X from the local buffer of the transaction that executed the write back to the database. This we call it as a simple transaction model. Next, storage structures. So storage structure. So what is the use of this storage structure? So everything in DBMS, okay. So whatever we are performing, we are doing anything here that should be stored somewhere, right? So that's why we need storage structure. Means we need to maintain the data in form of some servers that are of three types: volatile, non-volatile, and stable storage. Okay. So three types of structures will be there. One is volatile, second one is non-volatile, third one is stable storage. So here storage structure to understand how to ensure the atomicity and durability of a transaction, we again have a better understanding how various items are stored in database. Okay. So here, volatile storage. Coming to the volatile storage, so depends on speed, capacity, and resilience. Resilience is nothing but wherever we have stopped. Okay, wherever we have stopped the transaction, we can recover the things from there. That we call it as a resilience. Okay. Suppose, and during the third step, I have the transaction got failed. Okay, my transaction got failed. What will happen? From that onwards, it will recover the things. Okay, that onwards, it will be started executing again if the system is at good condition. Okay, so it depends on the speed, capacity, and resilience to failure. Storage media is classified into the following types like volatile structure, non-volatile, and stable storage. Okay. Coming to the volatile, information doesn't survive system crashes. So what will happen in volatile? Information will not be stored permanently if at all any failure occurs. That is called as a examples are main memory, cache memory. So let us have an example here. After writing some program, after writing any program, the programs will be reside in the hard disk. Okay. Why? What is the reason? Why should it be in a hard disk? Why not in main memory? Because all the programs, whatever we type the program, that will be saved in hard disk because hard disk where it is having the much amount of space when compared to the main memory. Okay. So volatile storage is nothing but information will not survive forever. So even any crashes, any failure occur means the information we lost. Okay. So Here examples are main memory and cache memory. Now, after saving and after typing the programs, during the compilation also, the programs will be reside in secondary disk only. Okay. So at the time of execution, the program is called from secondary memory to the main memory. Why? Because all the programs will be reside in secondary memory. And at the time of execution only, the particular program is called with the help of operating system. It is called to the main memory because main memory has the limitations. It will be having less amount of space and CPU will access only the main memory. That's why all the programs will reside in secondary device that are called to the execution for the main memory. Okay, so here example main memory is not permanent. Why? Because after execution, the programs will again go back to the secondary memory. Okay, if at all any failure occurred means what will happen? Here information will not survive even system failure occurred. That we call it as a volatile storage. So here the good quality it is there. It is extremely fast. Means the speed of memory access will be high. Okay, and it is possible to access any data item directly. Next, coming to the second one, non-volatile storage. So here information survives even the system crashes also. Now I said no, it is secondary storage devices like pen drives, hard disk. Okay, so all this magnetic disk takes flash storage. This we call it as a non-volatile storage. What happens? What is the advantage when compared to the volatile? Means information survives even the system crashes, even the system failure occurs. Example, secondary storage devices like magnetic disk, tapes, flash storage, etc. So here, when compared to the volatile, it is slower than the volatile structure. Means here, it will be having the random access. When compared to here, it will be having the direct access. We can access the items directly. When here, we will not access the data items directly. We can access only random. We will be having the privilege to have the access the random access. Okay. So here suspectable failures may lose information. So here it is also permanent by if at all we, for example, if we lost the device only, suppose I lost my pen drive. What will happen? I'll be lost in the information. Whole information will be lost, right? So information never get back if I lost the device. So suspectable failure may lose the information. That is what the difference between volatile and non-volatile. What will happen in volatile? Information will not survive even the system failure occurs. But here information will be survived even the system failure occurs. If at all a device lost means the entire information will lost. Okay. When compared to this one, non-volatile, it is slower than the volatile structure. Here we can access only randomly. Coming to the stable storage. Here never information will never lost. Why? Because the information will be replicated. Suppose here servers will be maintained in India. Like that only in US also the same server information is maintained. Like that, similar to these three servers, in UK it is also maintained and some other countries also it is maintaining the information. Means if at all in India we lost the information means we can recover the information from the other three countries. That is what information never lost. Okay. So information in by using the stable storage. Stable storage is nothing but servers. Okay. So if I lost in India, the information means we can recover the things from the three countries. That is what it is also called as a fault tolerant. Okay. Stable storage or DBMS will give a fault tolerance good feature. Okay. What is that feature means? If, the information never lost. Why? Because if at all in our country we lost means we can recover the things from the other countries. The information never lost. We can recover the things from the other countries. Okay. So that means what here? The information is replicated. The information is replicated in several non-volatile storage media. Okay. The same information is replicated in 4 countries. If we lost here also, we can recover the things from the other countries. So updates must be done with care here. Okay. And here it is also maintained the secure thing. In stable storage, it will be having the security mechanisms. Okay. So this is about the storage structure. 3 types of stable storage structures: volatile, non-volatile, and stable. Volatile in the sense information doesn't survive even system crashes. Example, main memory, cache memory. It is extremely fast. Okay, now coming to the non-volatile, information survives even the system crashes occurs. Example, magnetic tapes, disk, flash storage, etc. When compared to volatile, non-volatile is slower and it will have only the random access. We cannot access directly. Coming to the stable storage, information never lost. To implement this information, the replication of information is available in different countries. So whatever the updates must be done, so that should be done and that should be replicated every country. That may leads to consistent state. The database we can say it as a it is in consistent state. Clear? Yes or no? Next, transaction states. So coming to the transaction states, we have different types of transaction states. So first one is active state and then partially committed, then failed. Next one is the aborted. Last one is the committed. So here the to do any transaction, this is the execution steps. This is also called as the execution steps. We can follow 5 steps. What is the first one? Initial state. Active state is called as the initial state. So the transaction stays in this state while it is executing. Okay. The transaction will be stays in this state while executing the transaction. That is called as an initial state. Coming to the partially committed. So here it will perform the after the final statement. Which one? It will perform after the final statement has been executed. When it is going to done this one after execution, if at all the transaction is not performed or not successful, that may lead to failure state. That means the transaction will be aborted. Okay. So if at all the transaction is correct, means what will happen? The transaction will lead to the commit statement. The transaction will be in success state. Okay. This will lead to transaction success is nothing but commit statement. So the what is this first step? Active is nothing but initial state. The transaction stays in this state. Okay. So the transaction will stays in this state while it is in executing mode. Okay. So coming to the partially committed, it will perform after the final statement executed. What is the meaning of final statement executed? Suppose I want to transfer from A to B means read of A equal to A minus 50, write of A. So this will perform after write of A, after the final statement. Okay. Now, coming to the failure, after discovery, the normal execution can no longer proceed. Here, if at all any failure, anything happened means, so it will lead to the next state, that is failed state. So from this, the transaction got aborted. Aborted means which is not visible to the user interface. Okay. And here the transaction is executed successfully means this will lead to the next state, that is committed. So these are the steps. Aborted. A transaction may not always complete its execution successfully after the transaction has been rolled back. So here one more important point here in aborted. Again, we can go to the first step, that is active state. When means here after aborting the transaction, after doing the transaction got aborted, even this we can go to the first step, that is called the initial step. Okay, initial step. Then again partially committed. Next step is committed. Okay. So this is the steps are involved in transaction states. Committed is nothing but after transaction. Again, when we can restart the transaction means if at all the transaction is not having any internal logical errors. Okay. When we can restart the transaction, I said we can restart the transaction again, right? So after abort statement, again we can restart. When if it is not having any internal errors, we can come to the first step. That is what active step. Okay. So when we are going to kill the transaction means if we are not if we are having any internal logical errors means we can kill the transaction is nothing but we can stop the complete transaction. So these are the five states: active state, partially committed, failed, aborted, committed. Active state is nothing but a initial state. The transaction will stay in this state while it is executing. Partially committed is performed after the final statement. Failed is performed after discovery of normal execution. Will not be proceed for no longer. Next, aborted is nothing but the transaction will be stopped at middle. So it is not completed its execution successfully. So after the transaction will be rolled back again to the database. So that through the previous step that is active state. So two options will be having for aborting. We can restart again the transaction. When means if at all it is not having any internal logical errors, we can restart. If at all we are having any internal logical errors means we can kill the transaction. So after that one last step is committed. So this is called as a successful transaction. That we call it as a committed. Clear? Next one. So next one is the implementation of atomicity and durability. We already know the definition of atomicity, right? Either all of its transactions are done or none of its operations is called as a atomicity. Durability is nothing but whatever the transaction should be in persistent state. Okay, so how to implement these two, atomicity along with the durability means here recovery management component will be available. So the database system can be supporting the atomicity and durability. So atomicity will be implemented with the help of the concept shadow copy scheme. What is the concept shadow copy scheme? So what is mean the shadow copy scheme is it makes a copy of the database called as shadow copies. Okay, so whatever the database it is available, it makes the duplicate, it makes the replication. That is called as a shadow copies. It assumes that database is simply a file on a disk. Okay, what it is going to consider the database, whatever it is present, that is present on the file as a disk. Okay, so a pointer called as DB pointer is maintained on a disk. What it is maintained? DB pointer, database pointer is maintained on a disk. So it will points towards the current copy of the database. What it is going to do? It is going to show. It will points towards the current copy of the database. In to update the database, first creates a complete copy of the database. What it is going to do in shadow copy scheme means a transaction that wants to update the database. Okay, so first it is going to create a complete copy of a database. See, ma? So here in shadow copy scheme, first step it is going to make a copy of database that is called as a shadow copy. And second step, what it is going to do means it assumes that the database will treated as a file and it is present on a disk. Okay, so third point, a pointer, whatever the pointer is available, database pointer that is maintained on a disk so that it will show the current copy of the database. It points means it shows the current copy of the database. So what will happen in shadow copy scheme is the transaction that wants to update the database. Okay. Whatever the transaction wants to update in shadow copy scheme, that will be created first a complete copy of a database. Okay. So then all the updates are done in that new database, copy leaving the original untouched. See here. See, you'll be getting clear idea. So here, what will happen in shadow copy scheme? First, it is going to copy a complete database as one thing, and here it will maintain a database pointer towards the current copy. What will happen next? It creates a copy of this one. Okay, so that will be kept aside. Okay, now this will become as whatever the transactions, whatever the updations are done, whatever the updations are done, that will be maintained in a new copy of the database. Then the original copy, whatever the previous copy is there, that will be leaved aside. That we call it as a implementation of atomicity and durability. Implementation of atomicity and durability. This we call it as a shadow copy scheme. First, what will happen? It makes a copy of the database called a shadow copy. It assumes that whatever the database is there, that will be as a file on disk. And at a pointer, it is called as a database pointer. It will point towards the current copy of the database. So what will happen in shadow copy scheme? A transaction that wants to update the database will first create a complete copy of the database. Okay. Then whatever the transactions are done, that will be reflected in new database. The original copy will be leave like that only. That we call it as a shadow copy scheme. And this is also called as the implementation of atomicity. Okay. Next, transaction isolation. So how the transactions are isolation? As I said in asset properties, transactions are isolated. While because T1 transaction is doing, T2 will be in isolated state, hidden state. Okay. So multiple transactions are allowed to run concurrently in the systems. So how it is going to give advantage to the transaction isolation means it will increase the throughput and resource utilization. So one transactions can be using the CPU, while other transactions will be reading from the writing onto the disk. Okay. So if at all two transactions are there, one transactions will be using the CPU, while other transactions will be reading or writing from the disk. Next, second one is reduced response time from the transaction. So short transactions need not to wait behind long ones. What is the meaning of this reduced response time is whatever the response time, okay, given by the user. So here it will maintain the short transaction. No need to wait for the before transactions. Okay, that two advantages will have the transaction isolation. Multiple transactions are allowed to run concurrently in the system. So concurrency may leads to database to enter in inconsistency state while doing the multiple transaction that is called as the concurrency. So that will leads to database inconsistency. To overcome that problems, we go for the other mechanisms that concurrency control schemes. Okay, so before going to see the concurrency control, next one topic is schedules. Schedule is nothing but a sequence of instructions. Schedule is nothing but a sequence of instructions that specifies chronological order and a sequence order. Okay, a sequence is nothing but instructions. A sequence is the instructions which specifies chronological order in which instructions are running parallelly or concurrently. Transactions are executed concurrently. So sequence of instructions which specifies the order, okay, in which instructions of concurrent transactions are executed. A schedule for a set of transactions must consist of all instructions of those transactions. Okay, so let us take one example. Schedule, let a T1 transfer rupees 50 from A to B and T2 transfer 10% of balance from A to B. See here. So what will happen here? Schedule is nothing but it is a set of instructions follows the some order. Okay. So which transactions are executed concurrently means parallelly. So here in T1 T1 is nothing but transaction 1 and T2 is nothing but transaction 2. So here after doing the execution of T1, T2 is performing their action. Okay. So what is the question here? Let T1 transfer rupees 50 and two questions are there here. Okay. A to B and T2 should transfer 10% of balance from A to B. Okay. Two questions. What is the first question? Rupees from A to B and T2 is nothing but 10% balance from A to B. So first we need to do the 50 from A to B. Next we need to perform 10% of balance from A to B. So let us do this transaction T1. What are the operations we need to perform to do any transaction? Read and write, right? So read of A equal to A minus 50, write of A. Then read of B, right, B equal to B plus 50, write of B, commit. Commit is nothing but successfully this first transaction is done. Rupees 50 transfer from A to B. Next, coming to the T2, it should transfer 10% of balance from A to B. So this, what is our schedule? Schedule meaning is nothing but sequence of instructions that specifies the some order. So what happened here? T1 should perform this action only. Then only T2 is allowed to do the 10% of balance from A to B, right? So now T1 is done. Now coming to T2, read of A, temp equal to A into 0.1. Why? Because we need to transfer 10% of balance, right? So temp equal to A into 0.1. A equal to A minus temp. Next, write of A. Coming to the next B instruction, read of B, B equal to B plus temp. Write of B, commit. This is what schedule. Schedule is nothing but a sequence of instructions which specifies the chronological order which instructions of concurrent transactions are executed. If you observe here, two transactions, multiple transactions are performed, but one after the other. That we call it as a schedule. Clear? Next, see here, again, schedule 2, the other type of schedules, it is also called as a serial schedule. T2 is following T1. So after completion of T1, T2 transaction, T1 is allowed. So read of 10% of balance from A to B. Read of A, temp equal to A into 0.1, A equal to A minus temp, write of A, read of B, B equal to B plus temp, write of B, commit. So after performing 10% of balance from A to B, next what is the step? Rupees 50 from A to B, right? Read of A equal to A minus 50, write of A, read B, B equal to B plus 50, write of B, commit. Serial schedule. When we are going to call it as a serial schedule, when it is going to follow the chronological order, then after performing the T1, T2 should be allowed. Then we call it as a serial. But here in this example, it is not a serial schedule. Why? Because it is equivalent to the schedule 1. So after reading the instruction of A, so here the A operation is not performed. Why? Because the A account is deducted, but it is not shown in B's account, right? So before going to that step only, T2 is allowed to do the other transaction. So this we call it as a non-serial schedules. Non-serial schedules. So here schedule 1 and 2, sum of A plus B is preserved. Next, here the schedule 4, the concurrent schedule doesn't preserve the sum of A plus B. Read of A equal to A minus 50. It is not performing completely either A or either B here. Okay. So this we call it as a non-serial schedule. These are the examples of serial schedules. Non-serial schedules. Schedule is of two types, serial and non-serial schedules. Okay. So, what is the definition of schedule? A sequence of instruction that specifies the chronological order in which instructions of concurrent parallel transactions are executed. Next, serializability. Coming to the next topic is serializability. When we are going to say the given schedule is serializability, means the serializability is a process of used to find the given non-serial schedule is serializable or non-serializable schedule. What is the meaning of serializability? Means serializability is a process to find out given schedule is non-serial or serializable. So here Again, we will be having two types. Okay, conflict and views serializability. Before going to see this one, let me explain. In non-serial schedule is divided into two types: serializable schedule and non-serializable schedule. Non-serial. Okay, remember the terms that serializable is different, non-serial is different. Okay, non-serial schedule is divided into two types: serializable schedule and non-serializable schedule. Okay, so here coming to serializable schedule, so it provides consistent result. Which one? Serializable. Non-serializable, it will comes. If you observe here, we'll get to notice that by these two schedules, we can find that it is a inconsistent result, right? So here we can find that it is a the database is in consistent state. Here it is non-consistent, means inconsistent. The database is in inconsistent. Why? Because it is not happened in a serial until completion of T1. Okay, transaction T1 should be completed completely. Then only T2 should be allowed. Here, it is not doing so. Okay, not a, it is also called as a not a non-serial schedule. So here non-serial schedule, it will result not equal to transaction executed serially. So what is the difference between serial schedule and non-serial schedule? Serial schedule provides consistent result, whereas coming to serializable schedule, it gives non or inconsistent result. Coming to here, it gives a result equal to its transactions executed serially. When coming to here, it will not give a equal results when the transaction executed serially. Okay. So here non-serial schedule should not be permitted or executed whenever we want to find out the given schedule is serializable or not. Now here it will to find out these things, we need to look after the two things that are conflict serializable and view serializability. Okay, to find out the given process, given thing is non-serializable or serializable, we have two things, that is conflict serializability. Second one is view serializability. Coming to the conflict serializability, so conflict serializability is used to check whether a given non-serial schedule is conflict serializability or not. So it will perform the operations by converting given non-serial schedule into a serial schedule by swapping its non-conflicting operations. How it is going to swap its operations means, if we are performing any two operations, okay, any two operations on different data items, any two operations on different data items, they are called as non-conflict operations. What is, first of all, think it of like this. What is non-conflict serializability? Okay. What is serializability? We already know some set of chronological order, some set of instructions, some set of sequence of actions. Okay. That we call it as the serializable. So what is the use of non-conflicting means? Here it is a process. It is used to check whether a given schedule is non-serial or serializable. Okay. So here it is going to perform this process by converting non-serial schedule into the serial schedule. How? By swapping its non-conflicting operations. So how it is going to perform these operations means by converting serial schedule to the non-serial schedule to the serial schedule by swapping its non-conflicting operations. What are non-conflicting operations? Let us see here with four conditions. Okay. If two transactions are performing the operations on different data items, then those are called as non-conflicting operations. What are non-conflicting? Two operations, T1 and T2, are performing uh, operations on different data items like X and Y. Okay, then those are called as non-conflict. If operations are performing in same data items like A is a data item. So operations are performing on same data item is called as a conflict operations. So these can be used to check whether a given non-serial schedule is conflict or not by using four cases. What are the four cases? Means read queue, and read queue. What is the meaning of read queue, read queue? Here the operations are performed on same data item. What is the data item here? Queue. Okay. So same data item is queue here. So if the same data items are queue performing the same operations, read operations, means we call it as a non-conflict operations. Okay, because it is performing in the same data items. So next say case 2 is read queue and write queue. So here, if at all, if any one of the write operation is performed, that we call it as a conflict. Any one of the write operations is performed in conflict serializability, means that we consider as a conflict. Okay. Next, what is the third case here? Write queue, read queue. So any of write operation is performed, means then we call it as a conflict. So write queue, case 4. So this is also we call it as a conflict. So here you need to remember the main thing. Any of write operations is performed, then we call it as a conflict. Okay. So here it is performing case 1, it is different, right? So read of queue, read of queue. It is performing read of queue on the same data item, that we call it as a non-conflict operations. Non-conflict operations. What is conflict serializability? Conflict serializability is used to check whether a given non-serial schedule is conflict serializable or not. How? It performs the process by converting its non-serial operations by swapping its operations. These swapping the operations like case 1, case 2, case 3, case 4. These operations, by swapping these serial schedule operations, we can make it as a non-conflicting operations. Okay. So non-conflict are performed in the read operations. Example here, see. Non-conflict. So it is a given non-serial schedule. How we can identify it is a non-given non-serial schedule means. So here in middle of T1, T2 is allowed to do the transaction, right? So that's why it is called as a non-serial schedule. Now look at here. Schedule 3 can be transformed into schedule 6. Okay. To make a serial thing, okay, first we need to do the transaction T1, then we need to do the transaction T2, right? Read of A, write of A. Next T2 is allowed. So this we call it as a non-serial. Now how we are making it to serial schedule means read of A, write of A, read of B, write of B. So complete all of its transaction T1. Next go to the transaction T2. Read of A, write of A, read of B, write of B. So this we call it as a conflict serializability. How we are making this one? So this given non-serial schedule, we are making or we are swapping its non-conflicting operations, then making it as a serial schedule. Okay. Next one. This is also a non-conflict. So this we can make it as a conflict. Read of queue, write of queue, then we can make the T4 transaction. So that we call it as a serial schedule. Next one. So testing for the conflict serializability. So a schedule is a conflict serializable if and only if it is having a graph. It is called as a acyclic graph. Okay. Ti, Tj, Tm, Tk. Okay. So this is the cycle detection algorithm exists, which is taking the order of n square terms, where n is the number of vertices of graphs. Okay. So it is having the algorithm take n plus, where e is the number of edges. E is the number of edges. If the precedence graph is acyclic, serializability order, it can be maintained as a topological sorting of the graph. So here example is this is a would be either serializable or non-serializable. Okay. So this how we are going to perform the conflict means by swapping its non-conflict operations. Next one, view serializability. Next thing is new view serializability. How we are going to solve this view serializability means the schedule S and S. Okay, S and Q data items are two data items are available. Okay, so the two data items are available in the set means here we can perform the non-conflict operations. One second. So here two schedules S and S dash are there. Okay, so these are said to be view equivalent if it satisfies the three conditions. What are the three conditions? If each data item Q and the transaction Ti reads the initial value Q in the schedule S, then the transaction Ti must be in schedule S. Also read the initial value Q. What is the first condition? For each data item Q. So here one data item Q is present in the transaction Ti. Okay, so that reads the initial value of Q. Next, what happens here? The transaction Ti must be present in the schedule S. So this will leads to the initial value of Q. Next, what is the second condition? Each data item Q, if the transaction Ti executes read of Q. Okay, so in schedule S, then only what it is going to do means the value will be produced by a write of Q. So what happens here? We are initially reading the value of Q, right? Second condition, the value, the data item, whatever the transaction Ti is executing its read Q value, that will be present in schedule S. So that it should be produced by the write Q. Okay, so now read is performed. Then what is the next step it should perform? Write Q, right? So the operations will be executed by the transaction Tj. So what will happen? The read of Q operations is Q is performed on Ti. That must be scheduled. So and also read the value of Q what is produced by the same write operations. What operations done with the Tj. And third condition is for each data item, the transaction that performs the final write queue, the operation of the schedule must perform its final write queue operation. Then only we call it as a view serializability. So let me take other example also. Mm. So two schedules S1 and S2 are said to be view equivalent if it is following the conditions. First one is initial read. Like we have seen here three conditions, right? First one initial read, second one is update read, third one is final read. Initial read, update read, final read, right? Okay. So first one, it should satisfy the first condition, initial read. How it is going to perform the initial read? If T1 and T2 are given non-serial. So see, whatever the transactions we are performing, okay, when we want to do to the view, when we want to convert into conflict or view serializability, first the given schedule should be a non-serial schedule. Then only we can perform the operations. Okay, then only we can do the serializability as conflict or view serializability. Okay, next to satisfy the condition of the given schedules S1 and S2. What is the initial read here? Initial read of A is T1. So what is the update read here? Update read is not present in okay. So update read is present in T2. What is the schedule to initial read of B? T1, right? What is update read? T2. So these two are called as a view equivalent. Okay, view equivalent. It is not present here final. Okay. So read and write both are present. The initial read of both schedules must be same. Suppose two schedules S1 and S2. In schedule S1, if a transaction T1 is reading the data item A, and then S2 of the transaction T1 also should read A. Okay. So what happened here? Initial read of A is reading T1. In schedule 2, initial read of A is reading T1. So what is the next one? Second one is update read. So here, if schedule S1, TI is reading A, which is updated by the TJ, then S2 is also TI should read A, which is updated by TJ. Then only we should say it is the update read. So here, in a given non-serial S1 schedule, T1, T2, two are there. R of X is nothing but read of X, write of X. Here T2, read of X, write of X. R of Y, read of Y, write of Y. So here, how we are going to convert by swapping its non-conflict, right? Read of X, write of X. Next, read of Y, write of Y. Next, read of X, write of X, read of Y, write of Y. Now it is become as a serial schedule. Now let me check how it is view equivalent or not. So here, what is the initial read of X here? It is present in T1, right? What is the update read? Update read is nothing but A of right. So initial read. After write, it is present in T2, right? Next, final write of A, it is present in T2. Final write of X is present in, final write of Y is present in T2, right? So here, coming to initial read of data item Y is present, initial read of data item is written in T1. So update read is written in T2, right? So what is the final write of Y? It is in T2. So if you calculate here, initial read T1, T2, T2, here also T1, T2, T2 will be getting. See, I'll explain clearly. Now look at here. So to check whether it is a view serializability or not, we need to follow the three things: initial read, update read, and final read. Okay. So coming directly, I'm going with the example so that it will be clear for you. So we need to get the three things: initial read, update read, final read. Right. Okay. So we know that initial read. What is the initial read we are getting here? Both the things from this one. T1, which is present in T1, and here also in schedule to T1. So it is okay, correct. Okay. Next, coming to the update read. Here, update read of X. Update read of X is present in T2. Okay. So after this one completion, whatever the things made in next transaction, that we call it is the update read. Okay. So update read of X is present in T2. Coming to the next update read of Y. Update read of Y is present in T2. So both the things are available in T2 only. After performing here, write of X is here, right? So that's why update read is present in both in T2. X and Y are present in T2. Now coming to the final write of A. T3. It is present in T3. Here also it is present in T3. We call it as a view equivalent. Why? Because both the things, update read of X, update read of Y. Okay, final write of X, final write of Y, initial read of X, initial read of Y are having the same values. Okay, so see here. T3, T4, T6. T3, T4, T6. So what is the initial value of read of Q? It is present in T3. Now, initial value of here, read of Q, it is in T3, right? What is the update read of Q, which is present in after performing its operation, it is present in T4. Here also it is present in T4. What is the final write? Final write it is present in T6. It is also present in T6. Okay. So whatever the things are present in different transactions, that must be equal with the same data items. It is a view serializability. So here view equivalent serial schedule 3, T3, T4, T6. Since one read of Q instruction reads the initial value of Q in both the schedules, and T6 performs the final write in both the schedules. This we call it as a view serializability. So here next every schedule is also a view serializability. But there are view serializable schedules that are not conflicting the serializable T3, T4, T6 here. If you observe here, only one transaction it is available. Okay. So here from this T4 transaction and T2 are performing the write queue operations, right? Write queue operations without having any read queue operation. So write off this we call it as a blind writes. Only writes of this sort. Only T4 transaction is having write. So this we call it as a blind writes. Blind writes is nothing but it is appears in any view serializable schedule that is not conflict serializable. That we call it as a view serializability. Next, transaction isolation and atomicity. So here, how to recoverable things from the scheduled transaction isolation and atomicity is if the transaction TJ reads the data item from the previously written TI, so then it is committed. Means it is successfully done the transaction means T1 must appear before the commit transaction of TJ. So the following schedule is not recoverable in T9 commit immediately after the read operation. So this is the given schedule which is not recoverable in T9 transaction successful immediately after the read of operation. So here what we need to do, T8 should be aborted. Means we should stop the transaction. Again we can roll back. Again it will go to the initial step. So we would have read the things which is possibly shown to the user. So this will lead to inconsistent database state. So hence the database must be ensured that schedules are recoverable. This we call it as a transaction isolation and atomicity. Next, cascading rollbacks. So rollback is nothing but wherever we stopped the point or wherever we stopped the transaction, okay, in the database, again we can roll back, again we can go to the previous step, okay. Single transaction failure leads to the series of transaction rollbacks. So consider here following schedule where none of the transactions have been committed. Okay, suppose transaction T10 read A, read B, write A, and here the transaction T10 is aborted. Then coming to the T11, read A, write A, and next to T12 is read A. So here T10 fails means T11, T12 must be rolled back again. Why? Because to perform the operation of write of A, we need to perform again T10 transaction. Then only T1, T11 and T12 will be executed. So here CPU will be going some CPU wastage of work will be there here. Why? Because it is taking the time for the transaction 11 and taking the time for the transaction 12. So here usage of CPU will be wasted here. So cascading schedule is also known as cascading rollback or cascading abort. So these are the example of cascading schedules. So next coming to the dirty, previously we have seen blind writes, right? So here all the isolation levels disallows dirty writes. What is dirty writes? They disallow the writes to data item that has been already written on another transaction which is not yet committed or aborted. Okay. So what is the meaning of dirty writes? They disallow the writes to data item that already have been another transaction which is not committed or aborted. That we call it as a dirty writes. By default, isolations levels will be in read committed state. Next, 1 minute, ma. So till now we have seen about the acid properties and serializability and recoverability, implementation of isolation, testing of serializability like conflict and non-conflict view serializability. So next move to the topic log-based and timestamp-based concurrency protocols and deadlocks. And then we'll be seeing the B plus tree tomorrow session. Wait. So concurrency protocols, concurrency controls are next topic. It is having in other slides. Let me open and share with you. Next, concurrency protocols. So concurrency is nothing but it is a process of managing simultaneous execution of a transaction in a shared database. So concurrency is nothing but multiple transactions doing at a time. Okay. So it is a process of managing simultaneous execution of a transactions in a shared database. Example, ATM machine is there. So different people are accessing the same ATM machine same time, right? So different people will access the same ATM machine or different ATM machines at the same time. Call it as a concurrency actions or concurrency control. So all the customers of SBI account, okay, all the customers of SBI account will be withdrawn money of from the ATM machine, which is shared data. So multiple transactions done on the same database is also called as a concurrency. What is the definition of concurrency? Multiple transactions done on the same database. Multiple transactions will done on the same database called as a concurrency. Example, ATM machine. Different people will access the same ATM at the same time is called as a concurrency control. Okay, multiple transactions are done in the same database or concurrency control. So there are some purpose of concurrency control. Why we need to use the concurrency control or to enforce them into isolation. Everyone, whatever the using the database should be in isolation state, right? So then only the database will be in secure state. Purpose of concurrency control means there will be no same time at a time we are doing the transaction means there should be a enforced into isolation. That means the database should be in isolation state. Okay, so there will be no conflicts while doing the transactions. Okay, there should not be any conflictions or non confliction should be not be there been while performing the transactions. Okay, so here to enforce them into the isolation, everyone knows the using the database. Here, next one, to preserve the database is in consistency state. 1 minute, no? So, what is the purpose of concurrency control? Is first one to enforce them into isolation. That means everyone knows whatever the database it is available. Sir, meeting loan. Yes. So to know the purpose of concurrency control, to enforce them into isolation, everyone knows that whatever the database is available, that should be in isolation state. So next second, what is the next purpose is to preserve the database in consistent state. We need to maintain the concurrency control. Third one, to solve the conflicts. Like we already know about the read and write, write, like operations, right? So these are the operations to resolve the conflicts between the serializable, non-serializable. We go for the concept of concurrency control. What are the three things you need to remember? Why we need to use concurrency control means second point to preserve the database in consistent state. Third one to resolve the conflicts like read write. So these are the conflicts which is available, which are we are getting when we are using the transactions. To resolve that conflicts, we need to use the concurrency control. Next, there are some techniques to resolve the concurrency control. There are four techniques: log-based protocol, timestamp-based protocol, optimistic protocol, multi-version protocol. So log-based protocol here name itself it is defining, right? Name itself it is defining. It is a log-based protocol, locking the transaction. Okay, so what are the transaction we are doing? First, logging its transaction and doing the operation, and third step is releasing the transaction log by using the unlock. Okay, if you observe here any transaction like here, if you are performing any operations in log, going to perform any transaction read of A means here in the first step it is going to log its transaction. After performing its completion of operation only, it is going to release the transaction. That means by using unlock, it is going to release. Okay, so a lock guarantees the exclusive use of data items. What is the meaning of lock here? We are putting means giving a secure that it should be that means only one transaction is allowed, the other transaction should be in waiting state. Okay, so what is the meaning of lock guarantee here? Lock means it is giving a exclusive use of data items to a current transaction. Okay, so the first date access data item is whatever the transaction we are performing, first it is going to acquire the lock. That means first locking will be happen, then second step all the transaction done, the third step it is going to release completion of the transaction, it releases a lock. So there are two different types of locks available, shared lock and exclusive lock. Shared lock is also called as lock yes. Okay, shared lock is also called as lock yes, and exclusive lock is also called as lock X. Okay, shared locks with denotes with yes mode and exclusive denotes with X mode. Okay, so here the transaction can data item. What will happen in shared lock is the data item can be only read. S lock is used to or requested to use the lock of yes instruction. Okay, so what will happen here in shared lock? Only it reads the data item. Only it reads the data item. Okay, so what will happen in exclusive lock? It is used to write and read and write. Both it can do. It can perform read and write operation. Whereas in shared lock, it will happen only read. Okay, it can the data item can only be read. Here coming to the exclusive, it will perform both the operations read and write. Okay. So next here, coming to the in-depth of log-based protocol. Okay. So here log-based protocol, any number of transactions can be hold by shared log, but exclusive log can be hold only the one transaction at a time. Here coming to the log compatibility matrix, two data items are there, S and X. So if at all S is having the true, then it will follow the transaction should be logged. Otherwise, the transaction will be released. The by using the unlock concept. So the transaction may be guaranteed a lock item by other transaction. So any number of transaction can be hold shared locks on data items. So if any transaction holds the exclusive lock or item on the no other transaction may be hold on any other lock. So if a lock cannot be guaranteed that the requesting a transaction is made, wait until it is in incompatible lock held by the other transactions have been released. So the lock is have been guaranteed. So this we call it as a compatibility matrix. So see here example T2 is performing transaction T is performing lock yes. What is the meaning of lock is shared lock, right? So shared lock in the sense it is going to perform only read operation. Okay, here it is performing read operation. After completion of its operation only the transaction was be released on lock of A. Next it is performing lock yes of B. Okay, so here it is also of B. So unlock of B. What is the display? It is going to get display of A plus B. Okay. So locking is above is not sufficient to guarantee serializability. If A and B is updated in between the read and write, okay, read of A and B, so it is displayed would be wrong. Here it is performing the same operation only, then only we got the display A plus B. Otherwise, it will be getting the error. Okay. So locking protocol is a set of rules followed by all of its transaction. While requesting and releasing locks, lock protocols restrict the set of possible schedules. And one more thing here, you should remember that shared lock will only read, and whereas exclusive lock will be having two operations, read and write. So here, whether the transaction first it is reading means the data item will be locked here. The data item will be released after execution only. The data item will be released. Okay. So two locks will be available: shared lock and 1 minute.